Więc tak, ta ostatnia sesja jest przewidziana głównie dla projektantów, którzy chcą rozszerzyć te możliwości standardowe Revita o przede wszystkim dla mnie osobiście moduły obliczeniowe. Tak jak już koleżanka wspomniała na tej sesji, tę sesję poprowadzi pan Manfred Waluga, założyciel firmy liNear, który jednocześnie zarządza firmą wraz ze swoimi 2 synami. Pan Manfred po wielu latach bycia de facto programistą dziś zajmuje się głównie sprzedażą międzynarodową z partnerami takimi jak my. Firma liNear powstała w 1989 roku, no i niedługo po tym stała się liderem w integracji CAD-owskiej i obliczeniach w branży właśnie MEP. Od 2010 roku firma wspiera również rozwiązania technologii BIM, czyli Autodesk Revit, i aktualnie oferuje bardzo duże portfolio rozwiązań do projektowania i obliczeń właśnie w tym sektorze. Dzisiejsza prezentacja to przede wszystkim przegląd rozwiązań, które oferuje właśnie liNear. To tyle z mojej strony wstępu. So, Mr. Manfred, please start your presentation.
Thank you very much, Wojciech.
Okay.
So I share my screen directly and start with the presentation. Let me see. So I will give you a compact overview of the company and the possibilities of the software, and also about our approach to move forward building information modeling in the MEP sector. To start, let me briefly summarize who is liNear and what is our mission. So who is liNear? Founded in '89, located in Aachen, Germany. We today have 80 plus engineers and technicians, and we reached over these last 30 years 29,000 customer seats in Germany, Austria, Switzerland, and Luxembourg. So currently we have 60% of market share in Germany related to the number of MEP design offices. And for long years now, we are Autodesk OEM and industry partner now. Today, we have the most complete product portfolio for MEP designers. We support 7 languages and a lot of different standards. Our customers are mainly MEP designers, but also installers and the relevant manufacturers in the MEP sector. These are some of them. We have premium partners and other partners. These premium partners do marketing cooperation with liNear. So these are the ones that we are working for constantly. We deliver industry parts and calculation data free of charge for the engineer. And this is another brickstone, let's say, for in the liNear solution. These loads of manufacturer data, which they all individually also publish on their websites. And with downscaled OEM versions of our products, for example, for companies like Viga, Fissmann, or Rehau, we were able to reach these numbers of customers during the years. What is our mission? This is the one sentence. We enable MEP designers to design energy efficient systems in the most productive way. And we see this becoming more and more important because of different things. More and more people are going to live in big cities. This development is mainly taking place in Asia and Africa, but also will massively influence the building industry in Europe. There is a need to build better quality in less time, everybody knows. Second, in the context of global warming, MEP designers will play a key role in ensuring that heat load and heating and cooling buildings can meet comfort as well as energy efficiency and sustainability. So all this together is, let's say, a challenging task, and it needs good tools for this. And on top, the situations like we have currently with the pandemic showed us that in future we are thinking about different ways of collaborating from different locations. So these are all drivers for the digitization efforts in the building industry. And we at liNear are working hard and to deliver the best tools available. The MEP Framework is the title of this presentation, and I'll show you with this screenshot what I mean exactly. So we found that the MEP construction and calculation itself is complex enough. So we wanted to avoid additional complexity from the CAD system, where which helps to keep the productivity on a high level. Our customers normally are not interested to become a Revit specialist. They just want to be able to do their work. They think in their own terms. They think in buildings, levels, capacities, systems, and we offer the functionality in a way that supports their workflows. So here you see the screenshot with liNear solutions on top of Revit, and on the right part, you can dock these windows wherever you want. In my screen, it's like this. On the right part, you see the main control in the dialog bar of liNear for project settings, selecting levels, importing levels, selecting disciplines, and creating and selecting views. This is a thing that's heavily used during work. On the bottom, we have some quick access utilities, things that are really helpful, for example, to create a section view on the fly, to isolate components and any other functionality that makes sense in this context is shown on the bottom line. On the right, you see the linear properties and compared to the Revit properties of objects, it's really MEP specific. So what we see here is the property of a space, but presented in a way that you find the MEP related space attributes much faster than in the pure list of attributes that you find in Revit. And this is of course context sensitive, the element that you select, if it shows its own properties dialog. And finally, on the top, we only have some global functionality. It's something like IFC import table, classification, Excel import export, the managing of system classes, batch conversions, something like this. So which is not really during project work, but more or less generally set up things we placed on the top. So the major part we work with is here this dialog bar. And going one step further, I show you just one workflow in this example for heating. And you see what the different levels here, these tabs on the top, what they mean. There is first the settings, then the creation part, where it's about creating pipes, parallel pipes, making combinations of elements, linking elements to pipes and so on. The third part is a library part where it's all about manufacturer components, but also generic components. And it's a nice way to manage the content within your project. You have a search function to find the content, and you have different modes for insertion. So everything very compact in this one tab. For example, putting elements on a grid is quite easy here, or replacing elements can be done from here, or finding the family with this pipette symbol here. You just click on an element and you are shown which family was inserted for this. So this is the completion of the construction. Then the calculation, just for heating here in this case, you see there's lots of things. We have a short view into this later on. There's a lot of functionality only for heating, and it's very differentiated tool. And finally, the collaboration tab, where it's all about reports, issues, BCF, IFC for collaboration tasks. Everything is managed here. And so with this easy tabs, the whole functionality for creating heating and cooling systems is quite easy accessible. It's really context sensitive. You just move through these tabs and you find the things that you're searching for. So I prepared a short a live demo here to just go into a project and show some things, not really creation, but all the things that can be done. And where's my Revit screen? Here we see a small office building here, and shortly put this here. So, and yeah, what we can do here is quite easy. If we have a 3D view, we can really simply cut and see what is the building, the first floor looking inside in 3D. I can also go to the first floor and cut the ground floor if I like. So just focus directly with the 3D section box. It's, let's say, utilized here for this. So it's quite easy to use in 3D plans. On the other thing, on the other side, we have the floor plan things, and as soon as I select two floor plans here, I can select appropriate plans for the first floor. So all these lists here also work like search criteria for views. And if I go to potable water, you see it suggests first floor potable water because I was in the first floor, and if I just switch to the second floor, it opens up the view for potable water in the second floor. So this is quite intuitive to use and people like it, and it's much easier than browse to this lots of views that during project work really come up.
Sorry, Mr. Manfred, we see only presentation, not Revit, not live demo. So you should maybe stop share and change the window.
Yeah, let me see. I need to stop. I just thought I selected my desktop, so that's why I thought I was already. Thank you for telling me. So now you should.
No, it's still presentation.
Still the presentation.
PowerPoint, yes.
Let's see. Revit here, the one. So sorry for this.
Yes.
Yep. Okay.
It's good.
So I go back to 3D and show what I'm talking about the whole time. Just roughly to show you, if I deselect the story here in a 3D view, it just cut it, and I can take a look inside, and I can do the same from the bottom if I like, and just have the first floor here isolated for whatever task I like. And if I select floor plans here in the bottom, it pre-selects the floors that could fit for the first floor in the main building. It could have also building parts here. I don't have currently. So first floor architectural, it's so easy to select these. And for the second floor, it just selects directly the architectural plan in the second floor. So if I select a 3D view coordination, for example, I just see what 3D shows me here, and I can then, additionally to switching on and off different traits, I can, for example, switch all the components, the view categories directly from here. So I can switch off the building if I like, and just see the MEP systems. And if I don't want to see ventilation or potable water, I can just deactivate it from here directly. So if I go to potable water, I just see the potable water system. If I go to heating, I just see part of the heating system and so on. So this is quite easy. And in every discipline, I have the view categories available directly on my fingertips, so I can easily switch them on and off here while working. That's quite simple. So now I go to another workflow which is called space concept. This is something that's relatively new. The idea is that MEP designers should participate in the design process much earlier than they now do. So for example, if an architect is, let's say, in his conceptual stage, normally the MEP designer is not part of this. But the IFC classes provide, for a few years now, provide so-called provisions for space. So this is a good opportunity to just place spaces to tell the architect, this is where I want to be with my, for example, installation rooms, technical rooms. And if I click here on such a space element, the space boundary, and I go to the liNear properties, we see this is a space for sanitary installation. This is the space for cooling devices, and this should be the space for heating installation. As well as the spaces can be used for the technical rooms. They can also be used to predefine the major routing of the systems through the building. And this is quite simple. It's not more complicated than drawing just an air duct, but it includes directly data. You see here that we are able to just add data. We do not draw them individually, but the more data we add or different data that we add, the more can be done afterwards automatically. You see here we have heating flow and return and cooling flow and return. So this is just planned, it's not there currently. And with this approach, we can, via IFC, we can in very early stages already communicate with the architect and say, I need some space beyond the ceiling in the corridors or whatever. I need something here, I need a shaft there. And this is a very good entry. And after they agreed, the architect and the MEP designer, they agreed on things. I go to this drawing type of this. There is a command which says generate pipeline corridor. And I just implemented here some samples here. For example, let me see. Exhaust air supply air, generate pipeline corridor. Okay. I need to assign a cross section. Let me see. This is a cross section which tells something about how it's divided. And as soon as I did this, I can rearrange things however I like. When I then say generate pipeline corridor, what the program does is it creates the ducts. I switch on ventilation and we should see it. It creates the ducts elements, and it would create also pipes and everything, just as a preparation for my further construction work. So I can be very rough as long as I want, and with this very flexible and time saving. And at the point when I decide now it's time to move on with my construction work, I just reuse these early things for my further work. So this is the idea behind the space concept, which we support through the whole BIM process via IFC. Let me see, something about, I go, for example, back to architecture, ground floor, and some properties that we, for example, want to see from this room. We see here it's a cafeteria, it's heated and cooled and so on, or the temperatures that are relevant. This is much more complicated with pure Revit because lots of things are hidden in zones. But finally, it's something, or in the end, it's something that's related to rooms. We also implemented a zoning tool, which is quite easy to use. We can arrange things via drag and drop to zones. For example, if I take this office and put it to corridors, it's then implemented there. If I have a 3D view of architecture for and I make it transparent. Just a click here, makes it transparent. Then I switch on the rooftop and I go to shaded. So just to show you here, if I want to see a zone, I just click on this, and even though the architectural plan, of course, is linked, we are able to show all the things in linked files. So this is quite helpful to see how is my zoning, what did I assign, and is these right? So, and the zones, of course, carry the data which they then give to the rooms that are in the zones. So this is quite good handling for zoning, which is then used for heat load or cooling load calculation later on. Just this to show. Let me see. Then I select ventilation, 3D ventilation. This is the ventilation system of this sample. So if I double click on the discipline here, I see the title, ventilation, and I have the related commands or features for ventilation, just nothing more. So we directly can select dimensions and materials from here. We can select the alignment, and we can draw ducts. We can draw parallel ducts or parallel pipes here, which can be configured widely. So not just copying one in parallel, but having a bunch of pipes and ducts in one step. We can connect components, of course, with different options. So you see everything is happening in this dialog bar, very space saving. And if we select some options, we see directly if something is inserted or should be inserted or not, if it has a flexible pipe in the end or not. Everything is just set here, quite easy to use. And in case somebody is lost in the beginning, he just presses F1 and we have a really comprehensive online help with not only the description of the commands, but also the description of the concepts, so that it's quite easy to learn this software. Okay, let me go back. Just a word about panel heating. You see that we have one room here with panel heating, and these elements have their properties. It's a panel tempering circuit, and we have these feeding lines here and the elements here. You see the different geometry which is caused by these beams. And if I afterwards want to change something, it's quite simple. I say I don't want to see spiral but meander, and the spacing should be 100 millimeter. I say assign the settings, not simplified, and then this thing is updated in the drawing, and I can go on. So this is quite easy to handle, and things can be combined, of course, with a manufacturer component like we saw yesterday from Uponor, this BIM library. But we also support a lot of manufacturers with their calculation and system data here, as you see. This is to see in combination with linear building heating and building cooling, where the layout and the hydraulic balancing is done, and we get the valve settings from this and so on. So heating and library, let me see, I go back to heating. If we go to the library tab here, you see that we have a lot of this drop down menus, and that we have sometimes previews and sometimes not. This is our way to present the whole family content, even from locations that come with Revit or that are user defined. So if a user already has his Revit library, he can easily implement it here, and it's treated and shown the same way. So for example, now for the discipline, if I want a heat exchanger, I just click on this and have the heat exchanger on the cursor. First it's loaded, and if it's shaded, you see that it's in the project. As long as it's not shaded, it's externally just. So now next click and I have this heat exchanger here. So this is quite easy to use. I can search, for example, for valve, and I just see the families, 20 families, which have valve in their name. So, or boiler. And we have just this gas boiler here currently in the project. So, so this is quite easy to use. And as I told you, different modes for placing components on grids and replacing are directly here where it's about content. If it's about manufacturer content, then we open the liNear CAD browser, and the liNear CAD browser shows all the components which are available via our installation center, and you can really choose which manufacturer you want to work with. And you see a list of manufacturers, and if, for example, if I go to Buderus, I can step through these things down to the last element. And if I have the element, this preview, I get all technical descriptions here. I can select if I want detailed or 2D view just, and then insert this into Revit, into AutoCAD, whatever. So this is an interesting source of components, and also you will be notified if a manufacturer updates his content. If there is new content, you get a notification, and then you're free to update if you like.
Mr. Manfred, we can't see the content library. Yes.
Sorry.
Because it's only Revit.
Window,
yes.
Even though it's on the CAD browser, so let's say I don't switch now the window because I move on to the project here.
No problem.
So yeah, sorry for this. With Teams it's easier for me. Then configure insert modes, so potable water and calculations. To come to this point here. Potable water system is here with some circulation and connection types which can be done on the drawing tab here. If you want to connect components, you have different options. You can use crossovers, you can use ear elbows, you can loop things for cold water or for oil, and you see in the preview what you will get. And this is how this was built, quite easy. Click just the pipe and the element and it's done. And then afterwards, if this small system is set up, it has a starting point, which is here. And this is a net start element, which represents, let's say, the big pipe in the street. And if we now go to the calculate tab, we have the calculation for potable water. The calculation for potable water, just to show you the configuration, I hope you see the window now. Yep, okay. Yes. Shows that it's quite flexible because we support everything that's, let's say, constructed in Revit, which is related to potable water. This means customer can have his own names for systems, and he just assigns here, if it's not done automatically, he assigns the systems he has created. Then we have a lot of calculation parameters. For example, the standards for calculation, then building types, residential buildings, hotels, and so on, which is for simultaneity purposes. Comfort levels, which is for times when hot water arrives, and so on. Outside temperatures, pressure tolerances, everything. Dimension of closed circular pipes, zeta values, and so on. So you see here are lots of screws which are really for professionals. It's not just a black box where you press a button and you get a result. It's really a tool for professionals, and it's a very transparent calculation in the end. I will show you the whole calculation process is done just by clicking here. The components are detected, the network is checked, and it comes up with result dialog, and the result dialog is organized in a certain way. You see the flow path on top, and within a certain flow path you have sections, and within the sections you have the elements, so the real pipes and fittings. So this organization enables to see results and summaries for flow paths or for section parts, not only the element from the single elements. To get a pressure loss from an elbow is nice, but you want to have the pressure loss from a flow path and from the flow path that you want to see. So this is really powerful to use. And if you're just interested in flow paths, you can expand this list so that you just see the flow paths, and the same, for example, for the components. So these are all the components that make up this system. The individual results are not that important, but if somebody is interested, he can go there and take a look. Everything is very detailed, as I told you. Everything is very transparent. So our strategy is customer should be able to check if we are calculating right in case he's in doubt. If we find an error, we fix it, quite simple, but we enable the customers really to trust the calculation because they have everything that they need to check. Visualization is a nice thing in between. So if you want to see which dimensions you got from the calculation, you just display this. You see a small legend window here, and the colors show you which dimension you have on which places. So DN20 here, and DN12 here, and DN10 here in the circulation. So this is quite useful, and what you can do for dimension can be done for a lot of other things. For example, for pressures, for temperatures, for velocities, everything can be visualized here and shown as a temporary view in Revit. What to do with the results? Of course, there is something that can be printed. Let me see. It could be that this window, do you see the result window? Yeah. So you see a lot of data which is about the bill of material, more or less, which you can see here. But of course you can also see the results. Let me see. So you can also see the results of potable water. For example, the peak flow rate or the ejection time, that can all be shown here and shown in a preview. So lots of reports here, as I told you, very transparent to check. Very different things that you can select or unselect. And the other thing is that we can export parameters, and of course you want to have the results in S-shape parameters or whatever in your model. We do not prepare all shared parameters while inserting the element, because this would be a mess. A lot of parameters will never be used, and you just have a lot of garbage in there. So we decided that the customer can decide, depending on the design phase, what he wants to export really. For example, for a backflow preventer, you have this list of elements and parameter names, which you can check or uncheck, and then you just, you can publish more or less information, and the configuration for this can be saved and reloaded. So you can make a configuration for level of information 200 or 400, whatever you like, and for every element type you have individual data, of course, and you can decide which you want to publish and which not. This element data is then also very useful when it's about IFC export, and I'll show you shortly. Let's see. Linear, we have this classification here. If we want to export an IFC file, Revit is only dependent on the few categories that are implemented. It's not that much, it's just an MEP component or a pipe accessory, it's not that much. IFC is much more detailed, and to use this, we are using the classification that we also use for third-party content. So if somebody comes around with a nice family for a double pump, then he can use it with our calculations. The only thing he has to do once is classify it and tell it this is a pump. That's all. And with this information, we are able to easily, before exporting, make proposals for the correct IFC type and see what happens in this column here when I press this button. Okay, 27 classifications have been adjusted, and we have isolating, water filter, regulating, water meter, and also the fittings are bends and junctions and transitions. So this really makes or creates a good IFC export if you want to give, let's say, the next one in the chain better information. This is something that's supported here in this context. Classification, then the last should be, not to forget, the void planning. Provisions for void is something that, of course, everybody needs. And if I go to a floor plan, then we see here are such provisions for voids. And they are created, of course, based on the systems, on the ducts, pipes that are crossing walls and whatever. And this is done automatically with a special set of commands that you find here, of course. We can decide here if the architecture is in the link or if the MEP components are in the link. And depending on this, the program asks to click a link or an element. Then you can insert provisions wherever you like manually, but of course also automatically. And just a few inputs need to be made. And then you can make joins automatically or join them later on. You can export things, and this is where BCF comes to screen. You can export a BCF file, which can be used for collaboration with the architect. He can change the status and say accepted or denied. You import this BCF file afterwards, and you update your model with this, getting the accepted or the denied, and then go on with your work as long as it's not yet finished. So this is everything in here for slot planning, and you see it's not that much, but it's very powerful. So it's quite easy to learn and supported with the online help. It's something where customers don't need weeks or months to get to see the whole possibilities of the software. So this is let's say an overview. I need to stop and go back to the PowerPoint again.
Okay. We have one question.
Yeah.
But in German language. So if you could go to the question and answer option, maybe I translate it via Google Translate.
Ist es möglich aufgrund der Architektur? Yes, this is possible, of course. We have a product module, and I will show this in my slides afterwards, which is called Building Analyze. And Building Analyze does nothing else than analyzing the Revit building model and organizing all the elements for calculation. And then in linear building, we have heating load and cooling load. And the building's geometry is then taken automatically for calculation. And if your model is well designed, you don't have that much manual work. If your model, let's say, misses all U values, then you can insert them in the calculation, or you insert them in the model. But if you have no chance because the architect is not willing to care about this, then you can do this. But yes, cooling load and heating load is possible. And there is a lot of videos on YouTube about this. So, yeah.
I have a question.
Yep.
Is it possible to use my own families to the calculations, for example, fittings or?
Yes, of course. Of course. This is, let's say, a philosophy. Because we are international, we cannot force people to work just with our families because we just see a small part of the whole world. Everybody has his own demands, his own families. The only thing that's necessary to use it for calculation, as I told, is classification once.
Okay.
So you just, let's say, let the program know what this family should be, because the program cannot take a look and decide. And then afterwards, in every new project, it's then known as your pump or your control valve. And yes, and as I told, the own components can be used also in our library tab, and your own components if it's about fittings and pipes. So routing preferences can be used or can be used also, because we just, for example, with Upano, we did the same. We have just an external file where everything is in the routing preferences as well as the fittings families. And with an XML file, XML snippet, we tell the program there is something, take a look, and then it offers the pipe dimensions and the pipe types that are in this drawing, and you can use it. And then the routing preferences are loaded on demand. They are need not to be in the template. They are loaded on demand when you need them. And with this loading of the routing preferences, all the families are loaded. So this is quite flexible, and we keep the template clean. When you start with a linear project, you don't need to have anything preloaded. Everything is created and loaded on demand. Okay. So this keeps projects clean.
Okay. So I think there is no question at this moment. So thank you very much, Manfred, for your professional presentation. And Claudia.
Two other slides.
Two other slides. Sorry.
Yeah, just shortly.
Okay.
You see my presentation?
Okay. Yep. No. Yes.
Okay. So design steps and project families. Maybe this answers also some questions. Preparing the architectural model, doing thermal load calculations and layout of system devices is done by linear building for analyze heating and cooling. Design of system topology, creation of pipes and duct systems and void planning is done by linear desktops. And dimensioning and balancing, bills of material and handover to IFC FM is done by linear analyze. And one word about this modularity. The idea is that not everybody is interested in ventilation or in potable water, and not everybody is doing thermal load calculations. So the customer gets really exactly the modules that he needs. You just don't have to pay for something that he doesn't need. The summary, we have the complete portfolio for MEP designers. It's very modular for tailor-made entry. It's a scalable system. We have this workflow approach, which makes it much easier to go through this whole functionality. And we have dedicated calculation software for qualified engineers. So that's it. And now it's done. And thank you very much for your attention.